Hello, this is Warren Powell. This is part 3 of the Universal Modeling Framework for Sequential Decision Problems. This is on the Universal Modeling Framework. Now, the biggest challenge when we're making decisions under uncertainty is modeling. I want to take a real-world problem and put it on the computer. Everybody who works in the field of deterministic optimization or machine learning knows how to write out their problem mathematically. It's a standard approach. It's widely taught. Once we get to the sequential decisions, it turns into a big mess. Every one of these books actually represents a different field or subfield. The book on optimal control, there must be 10 or 12 different books on optimal control. It's a whole community. There are 8 different notational systems. They each write their problems differently. They don't know how to write objective functions. They don't know how to write what they're optimizing over. It's a complete mess. We're going to fix that mess right here in today's talk. So here we are with a single PowerPoint slide where I'm presenting what I'm going to be calling the Universal Modeling Framework. Now, if you're at time t, st is the state. That's what we know or believe. That's your data. That's your information that's relevant to the problem. Once you have what you know, this is your decisions. This is what you control, where you reach out and say, I choose this out of a set. And then there's the information that arrives from outside the system that wasn't known when I made the decision, which also means it's random. Now, every time you make a decision, I can have one or more performance metrics, so I compute that. Now, decisions are made with a method that we're going to call a policy, which we design later. This is the major point of departure of how I approach problems versus all of those other books on the previous slide. I'm just going to plug in this generic piece of notation and say, okay, this is how I'll make decisions. I will design that later. And we're going to actually get to that in part 4 of the talk. So we're going to just leave that as a generic function. Now, state variables evolve. Tell me what state I'm in. That is, tell me what I know, or maybe I just have an estimate of it. Tell me what decision I made given the state. Now, tell me the new information that arrived that I didn't know at time t. The state transition model, SM, then tells me the updated state. Okay. Now, eventually, I would like to come up with a policy, and I'm going to evaluate the policy based on how well it works over time on average. Now, if you take all those variables, there's no new notation here. I can divide it into 5 components. These 5 components are the Universal Modeling Framework. I can model any one of those problems off to the right-hand side, any sequential decision problem, and any problem in any of these books. This is what I mean by being universal. Okay. Now, I still haven't defined the policy. We'll get to that momentarily. That'll be in part 4. Now, one thing I want to point out is when I identify my metrics, decisions, and uncertainty in the framing from part 2, metrics provides in English what I'm trying to minimize or maximize. Okay, so those are my metrics, but the metrics are done in English, and it always has to start in English. Then I have to say what my decision variables are, again in English. And the uncertainties, that's the exogenous information. The uncertainties, again, in English tells me what are my sources of uncertainty that are going to impact my problem. Now, I describe it this way to emphasize I haven't done everything. So first of all, I haven't designed the policy, and I haven't designed the state variables. Those come later, and I'm going to touch on that just momentarily. So I don't know the state variable, which also means I don't know the transition function. So I'm not totally done when I've done metrics, decisions, uncertainties, but that's foundation. I'm not going to get to first base until I know the answers to those 3 questions. Now, what comes next? So first of all, of course, I want to be able to design a policy for making decisions. Then once I have that design, I have to identify the state variable from the policy, the performance metrics, and the transition function. So these are 3 functions that depend on the state variable. What I need to do is to look at the information these function needs. That's my state variable. So here I have a path for saying, what do I need to do to make my decisions and improve my system? Now, the state variables will consist of what we know and what we don't know. I may have information where I'll say, yes, I would like that, but I don't have it, so I need to estimate it using any one of a variety of techniques. So this process allows us to identify what information is needed and what has to be estimated using machine learning. Now, I like to describe policies in this way. So steam engines turn the energy in coal into a force that propels the train forward. Policies are the engines that turn information into decisions to drive companies forward. Information is like the energy going into the engine. It's just that information isn't like coal. Information is more like a buffet. It's got all these different types of food and all different flavors and styles and whatnot. It's very complicated. Anybody dealing with data knows how many flavors that comes in. Now, this buffet is my state variable. And the state variable, more specifically, I'm going to have everything I know about physical and financial resources, people, equipment, cash, investments. There's an information class, which is functions, objective function, forecasting methods, and then the parameters that are used to calculate these functions. And there's various parameters that are used. And then I have a whole third category, basically for beliefs. This has to do with anything that I don't know perfectly and that I have to estimate. Now, when we make decisions, let's assume that we make decisions in the decision factory, okay? Now, I'm going to describe the flow of information the way we might describe a supply chain. So we have information like sales history, input from the sales department, market surveys, goes through a machine learning model, and out comes a sales forecast. I have similar activities with the plants and parts and materials, and then with people. And these all come together and create what I call the state variable. This is the information that we need. And that's the input to my decision factory, which is the policy. And the policy then makes decisions. So this is how we have the flow of information and then making decisions in a way similar to the way we might depict a supply chain. Okay, so that is the end of my universal modeling framework. If you are someone who is not into analytics, what the universal modeling framework is doing is to say, look, even if you do framing with no analytics, that framing process is motivated by what we would need if we were to do a model. Now, next is designing policies, and we'll do that in part 4.